Okay, let's look at an example. This is practice quiz 2-1b. Solve initial value problem. So we're given x plus 2 squared y prime equals 5 minus 8y minus 4xy with initial condition y of 0 being 1. So we're going to show that this is a linear differential equation, and we'll apply theorem 1 then to solve it. So let's first realize that it's a linear differential equation. So let's see, step 1, let's divide both sides by x plus 2 squared. So doing that. Okay, so dividing both sides by x plus 2 squared, we get y prime here equals this guy on this side. Now these two terms here, the negative 8y and the minus 4xy, I'm going to factor a y and a negative 4 out of these two. So factoring a negative 4y out, we get then the following. Okay, so I factor negative 4y out, and then I have x plus 2 here. Well, actually, I guess it would be actually 2 plus x, but I wrote it as x plus 2 here. Okay, then I'm going to break this into two fractions now. So doing that, we get the following. So breaking up, we get like this. I can cross off one factor of x plus 2 off here. And I want to move this guy to this side now. So doing that, we get... So moving across, we get this. I wrote it as 4 over x plus 2 times y, because I want to realize now that this is a first order linear differential equation. So this is something we can apply theorem 1 to. So this would be the p, and this would be the f. So let me write that. So again, this is my p, this is my f. So using theorem 1 then, we have the following. So by theorem 1 then, we're going to let our u of x be, well, it's going to be e to the integral of p dx. Here our p is 4 over x plus 2, so it's going to be e to the integral of 4 over x plus 2 dx. I can bring a 4 outside the integral, and the integral of x plus 2 would be ln of x plus 2. So this will become then, so it'd be e to the 4 ln of x plus 2. I can bring the 4 up now on the power here. So doing that, we get then, so it'll be e to the ln of x plus 2 to the 4th. The e and ln cross off, just be x plus 2 to the 4th. So that's my u. Okay, now let's use the next part of theorem 1. Okay, so now we're going to use the next part of theorem 1, which says that u times y derivative equals f times u, where the f is this guy and u is the x plus 2 to the 4th. So let's write that in our case. Okay, making a substitution. So again, our u is x plus 2 to the 4th. So it'd be x plus 2 to the 4th times y prime. The prime here means derivative with respect to x. And then the f is the 5 over x plus 2 squared multiplied by my u, which is x plus 2 to the 4th. So some cancellation will occur here. For example, this will cross off and this will become a 2 up here. So now let's integrate both sides. So integrating both sides, we'll have integral of x plus 2 to the 4th y derivative dx equals integral of 5 x plus 2 squared dx. Now on this side, since you're integrating a derivative, we'll just undo it. So it's just going to become x plus 2 to the 4th y. And here, you could do a u substitution. I'll let you check. But this is going to be just x plus 2 cubed over 3 plus some constants. Let me write it out here. So I get this, x plus 2 to the 4th y equals 5 x plus 2 cubed over 3 plus c. Let's solve for y now by, we could divide by x plus 2 to the 4th, or another way you can think of it as multiplying by both sides by x plus 2 to the minus 4. So let's do that. Okay, so multiplying both sides by x plus 2 to the minus 4, you'd be add the exponent, so this would be x plus 2 to the 0, which is going to be 1, so it's going to be y on this side, and it'd be minus 4 on that guy, and then c x plus 2 to the minus 4. Okay, so I'll get this. Now I'm out of space now, so I'm going to erase a few things and keep going. Okay, so we have it here now. Now let's find a c value by using our initial condition. So we're going to put 0 in place of x here and here, and 1 in place of y. So doing that, we get then. Okay, so again, y of 0 equal 1 means put 0 in place of x, so put 0 here, and put 1 in place of y, so put 1 here. So 2 to the minus 1 means 1 over 2, so it'll be 2 times 3 would be 6 here, and this would be c over 2 to the 4th. Let me write that. So I'd have 1 equals 5, 6 plus c over 2 to the 4th. But 2 to the 4th is 2 times 2 times 2 times 2, so it's 16. So I can replace that now with 16. So doing that, we have 16 here. Now let's solve for c now. It says multiply both sides by 48, so doing that we get 48 here, and then 48 times 6 into 40 goes 8 times, will be 5 times 8, and 16 to 40 goes 3 times, will be 3c here. This is 40, take this across, and then divide by 3 we get then. C is 8/3, so let's write our final answer now. So our final answer is, so here's our final answer, so I'm just replacing the c up here with now 8/3. So it'll be y equals 5x plus 2 to the minus 1 over 3 plus 8x plus 2 to the 4th over 3. That's our final answer. Okay, so we're done.